This is the circuit schematic diagram for a resonant circuit oscillator or a tuned circuit oscillator. Which is the tuned circuit here? You very well know that this portion, see this portion is the tuned circuit. We have this portion here. Actually, this is transformer. Our tuned circuit is this much only. You must have studied about tuned circuits when you were studying basic electrical engineering. So this is basically LC circuit, and you must have studied that in this type of circuit the resonant frequency that is given as omega 0 is equal to 1 over LC, root over LC. So this is the frequency at which this circuit operates. Okay, so omega 0 equal to 1 by root over LC. This is the first thing that you should note down. Now let's understand this circuit. Why it is tuned circuit? You know that because LC is tuned circuit. LC is actually called tuned circuit. Let's see this picture. This is a transformer and the windings are such that there is a shift of 180 degrees when a signal crosses through this. See, this creates 180 degree shift. If the signal has zero phase difference at the start, it will have 180 degree phase difference after this point. So this transformer actually creates first 180 degree shift in the original signal. Then this circuit. Now the gain creates the next 180 degree shift. You know, both in this and this case the gain is minus. So the next 180 degree is created by this drain to source, and there you have collector to emitter. Clear? So this is base, this is emitter. 180 degree shift here and 180 degree from collector to emitter, and similarly 180 degree here and then next 180 degree here, so that the net phase shift is 0 degree, one in positive direction, another in negative direction. So we have net phase shift of 0 degree. Okay, so we have achieved 0 degree phase shift through this particular network. What is the role of R1 and R2 here? RE, here we have RG. So these actually are for stability purpose. This circuit, both this circuit and this circuit, is operated in class C mode. So the transistor biasing is done in such a way that this circuit and this circuit, both these circuits operate in class C mode. So the next thing to remember is that the two circuits work in class C mode. Okay. So you have done so many problems on BJT, so this is not a very big complicated issue for you. Let's analyze this FET circuit a bit more. Okay, so the V secondary, that is, if we consider this transformer, then V secondary to V primary, this is basically equal to M by L, where M is the mutual inductance between these two coils and L is the inductance that you know, the self inductance. So first expression to be noted is this, not first was omega 0 equal to 1 by root over LC for tuned circuit. The second expression you should remember is V secondary by primary is M by L. Okay, and we know that AV is equal to minus mu, where mu is the amplification factor for field effect transistor. Okay, and according to Barkhausen criterion, there are two conditions to be met for oscillation. First is phi should be equal to 0 or equal to 2n pi, and second is minus a beta should be equal to 1. Okay, now this is V secondary by V primary. See, V secondary, that is in this to this ratio is actually what? Beta. This is what you are, from output to input, you are getting into from output to input. So this is the feedback network. So let's put it, A is basically AV here. So this is minus mu, so it becomes mu, and beta, we have beta equal to M by L equal to 1. So what you get? You get mu is equal to L by M. Okay. So this is the second expression you should keep in mind. And one thing, what we are considering, that the resistance in these coils or in this coil is very low, because practically it's not possible. You have very small resistance that actually creates decaying wave response, but in theory what we are considering is that this resistance, that is the resistance and inductance in this coil, is very low. But if that resistance is not so zero, it has certain resistance. Let's say it appears like this. This is R, and let's say the drain resistance is RD of the field effect transistor. Then the difference that it makes is, I am writing the expression, omega square. Omega 0 square was 1 by LC. So this omega, which omega? Omega that has changed from omega 0 because of this resistance R, is given as 1 by LC into 1 plus R by RD, where R is your resistance of the coil and RD is drain resistance of the FET. So this is, you should keep in mind. Another expression, another formula that you should keep in mind is GM is equal to mu into R into C by mu into M minus L. What is GM? GM is called the mutual inductance of the FET or the transconductance of the FET. More popularly it is called the transconductance of the field effect transistor. So GM is given by mu into R into C. This is C. This is R. Mu, you know, that is M by L, and then mu M minus L. So this is GM. And for field effect transistor, you know this relation, mu is equal to RD into GM. So you should keep these formula in mind. If any problem is asked, you can put the values and get the result. Okay, so this is resonant circuit. It is also called tuned circuit oscillator. And I told you this combination, what it does, it gives biasing to the field effect transistor. There we had R1, R2 and R2 with a C. So they were providing an RE also in the BJT case. So they were providing biasing to the overall circuit so that the transistor or the amplification is in class C mode. Clear? This is all about resonant circuit oscillator that you need to know.